students to the new chapter Wave Optics. We have already studied the light by considering its ray nature in the chapter Ray Optics, which is also known as Geometrical Optics. This is the next chapter after Ray Optics, where we try to understand what is the nature of light. Now first let us try to list out what we are going to learn in the chapter. So we are going to learn the theories on light, then Huygens principle or wave theory, reflection and refraction using wave theory, Doppler effect of light, interference, diffraction and polarization. Now we start with the theories of light. The light is an inevitable part of life. So therefore, from ancient pits, the people were curious in understanding what light is and what it is made up of. So initially, let us try to understand what these ancient people had an idea about light. In Western world, the thought process is recorded from the Greek civilization. So all the scientific study which have happened in Western world are attributed to have their beginning with Greeks. So after great study of light among Greeks, Aristotle said that the essence of light is white, whereas the colors are made up of mixture of lightness and darkness. Now to elaborate, the real nature of light is white. When we say light, it is absolutely white. Then why do we see different colors? So according to Aristotle, the different colors are due to the combination of light with certain amount of darkness. Now for example, if I say red, the color red is obtained due to the combination of certain amount of lightness and certain amount of darkness. If I change the amount of lightness and darkness, then the color may not be red, it may be say yellow. If I still change the amount of lightness and darkness, it may be green. If I still change, it may be blue. If I still change, it may be orange. So different amount of lightness and darkness tends to produce colors, was the thought given by Aristotle. In 10th and 11th century, the Arabic world was curious about light. A mathematician, astronomer, physicist, doctor and philosopher called Ibn al-Haytham puts a question: why does the moon appear larger near the horizon than it does when higher up in the sky? Now we understand that the question is raised due to the happening of a phenomenon called refraction. We Indians were never ever far behind from anybody. In 14th and 15th century, there was a great empire called Vijayanagara. There was a minister in the court of Bukka I, the emperor of Vijayanagara Empire, who was also a scholar. Sayana wrote the commentary or bhashya of Rig Veda. And in his commentary, at a point, he quotes that the velocity of light is 3 lakh kilometer per second. When we compare the value given by Sayana to the value that we use today after performing various scientific experiments, he is best suited. So we also had certain idea about what light is. Much before Sayana, in Vedic period, in Shukla Yajurveda and Taittiriya Samhita, a quote comes which says that the moon gets the light from the ray of sun called Sushumna. Now what does this mean? This means that the moon does not have its own ray of light. Aryabhatta further explained that the reflected sunlight is the cause behind the shining of the moon. So we knew the phenomena of reflection. Now these were the theories given by the ancients. If we limit ourselves to the text that we read, we go with the recorded models of light, recorded theories of light. So we limit our theories to these 5 eminent scientists. Now first one with Isaac Newton, second one with Christian Huygens, third one with Thomas Young, fourth one with James Maxwell, and fifth with Albert Einstein. Now let us try to understand one by one what these eminent scholars have told about light is. What are their theories? In 17th and 18th century, the light was thought to be comprised of colored particles. Now, this theory was given by Sir Isaac Newton. In 1672, he announced in his new theory of light and color that the light is a mixture of various colors having different refractivity rather than pure white light, as proposed by Aristotle, and demonstrated his theory in the famous book called Optics under the title Light Particle Theory. And to show his theory, he used a working model where he made the white light to pass through the prism, and the prism produced the colored ones. So to understand the Newton's theory, we go with this diagram. So when white light passes through the prism splits the white light into various colors, which means that white is not the real essence of light. The real essence is, or the light is made up of the particles of different colors. When these different colored particles come together, they appear white. So this was the theory given by Isaac Newton. At the same time, on the other hand, a parallel theory on light was given by Christian Huygens, who says that light is a wave. In 1690, he published a paper on light advocating his theory that the light is a wave or a wavefront. He used the phenomenon like reflection and refraction to explain the theory. He had to debate a lot, and after that only his theory, called Huygens theory, became the mainstream scientific constant. And to understand the wave theory of Huygens, let us see this diagram. When the white light passes through the prism, it gets split into various colors, but the splitting here is not in the form of particle as it happened or as it explained by Newton. Now here it is in the form of waves. Now in the diagram we see the red color having the largest wavelength, whereas violet having the smallest wavelength. Then in 18th and 19th century, the wave theory which was proposed by Christian Huygens was supported. A proof for the wave theory of light was given by one more scientist called Thomas Young. Thomas Young took 2 pinholes and illuminated those with light, and these produced the beautiful pattern called interference pattern, which had alternating bright and dark fringes. So this was a property. So this exhibited that the combination of energy and redistribution of energy is possible only if the nature of light is wave. If the light was a particle, then the particle coming from 2 different slits would collide and would produce a scattered pattern, not a regular one. Now to understand this, let us see this diagram. So when the light passes through 2 pinholes, we find alternate bright and dark fringes. It is possible if and only if the nature of the light is wave. If it was particle, then you can imagine the particles which have been thrown into the space by two different sources would collide, and if they go and hit some screen behind, it would produce a very random effect. You don't have any regular pattern, but here we got a regular pattern which consisted alternate bright and dark fringes. We'll understand this later in detail. When the light was further studied, one more important theory was given in 18th and 19th century with the prediction of existence of electromagnetic wave. James Clerk Maxwell in 1864 theoretically predicted the existence of electromagnetic waves, and he says that the electromagnetic waves propagate with the speed as the same as that of light, or in other words, light is an electromagnetic wave. Now, to understand the nature of electromagnetic wave, we have this. We have electric field vector and magnetic field vector mutually perpendicular. So here electric field vector is along y-axis, magnetic is along z-axis, whereas the wave is propagating along x-axis. So even after getting this, the understanding of light was not perfect. In 20th century, the light was called to have a photonic nature. The light was said to be a photon. Now, what does this mean? The photon is an entity which is neither a particle nor a wave. So, the photon nature makes the light to have a third kind of nature, neither particle nor wave. Now, what does that mean? Then why did the people before the proposition of photon theory called it as particle and called it as wave? The reason is, when the light interacts with various matter objects, in certain cases, after certain phenomenon, it exhibits the property which is similar to that of waves. But in some other cases, it appears to be having particle nature. So this photon nature was explained well by Albert Einstein after he produced the research paper in 1905 on his great photoelectric effect experiment. So now the light is neither a particle nor a wave, but it have the third kind of thing. Now in our content, in our syllabus, we are going to discuss this nature of light in one of the coming chapters, dual nature of radiation and matter. I have tried to show you what Newton's thought was with a diagram, what Christian Huygens' thought was, and how did the Thomas Young and James Maxwell gave their representations. But I fail here to give the picture of photon because photon do not have a regular picture. But still we'll understand what photon is, as I said in the chapter dual nature of radiation. Now after all these theories, the question comes, what is wave optics? The wave optics, which is also called physical optics, deals with the study of various phenomena such as polarization, diffraction, interference and other occurrences where the ray approximation of geometric optics cannot be done. Thus, the section of optics that deals with the behavior of light and its wave characteristics is said to be wave optics. The next question comes, why wave optics? The geometric optics neglects the diffraction of light and assumes that the light from a point source is focused into a point image. This is not the case. When the light passes through the aperture such as the iris, lenses, diffraction occurs and the wave spreads around the edges of the aperture. As a result, light is not focused into a sharp point but into a diffraction pattern consisting of disk surrounding by rings of diminishing intensity. Now to connect with our experience, those who wear spectacles when we see the street lights, bulbs at night, now rather than experiencing it exactly as its structure is, what we find is, what we experience is that there is a bulb at the center, whereas there are rings around that bulb. So these rings are formed due to the phenomenon of diffraction, which could not be explained using ray optics or geometrical optics. And this is true for all the cases where we use the lenses. So thus we start the chapter wave optics with this small introduction. Thank you.